Hey everyone, I just wanted to make a quick video to show you how to use JMP to begin exploring your data set and do a two-sample t-test as well as a chi-square test for independence. So I have JMP Pro open here and I'm going to select a data set. This one is the North Carolina birth records data set. And if we just bring that up and take a quick peek through here, you can see that it contains data on a lot of births in the state of North Carolina, the gender of the baby, maternal age, gestational age, marital status, lots of interesting variables related to these births. And maybe one of the interesting variables that we'll consider here is premature birth. And a natural question that we might want to explore is, are there other variables that are associated with prematurity? And for the purposes of this example, I'll choose another continuous variable. This one is obviously categorical, and it just has two levels, whether it was term or premature. And we can see if it's going to be associated with, let's say in the end we want to test to see if it's related with maternal age. So that's a continuous variable, and we can start exploring, those variables. For instance, maybe I want to see the proportion of premature births within this data set. So I can come up here to Analyze and select Distribution. And then I'll just take premature birth, and you can double click it or click and then click on these Y columns, or do what I just did and drag it over here into the Y text field, and then click OK, and it just comes up with a little breakdown of the distribution of premature births. So about 11.5% of the births in this data set were premature, and the other 88% were term. Right? So we can then start to see, all right, well, it looks like maybe about 11% of these were premature. What is the average age of the mothers that had preterm deliveries? And what is the average or median age for the mothers that had term deliveries? So I can start to address that question. Now if I come back over to the Analyze tab, instead of distribution, I will select Fit Y by X, and I will put as my response variable, I'm going to put maternal age in there, and then I will put premature birth in as my X or my factor level, and then just click OK. And this brings up sort of not a lot of information by default, but it turns out that a lot of the things that I might want to know about maternal age versus preterm delivery can be found just within this window now. So if I click on this little red triangle, it brings an extensive drop-down menu up. So maybe I want to know what the median ages were for those that were term and preterm. So here I see that the median age for term deliveries was 27, and the median age for the premature deliveries was 25. I can also use the 25th percentile and 75th percentile to compute things like the interquartile range, and it gives me some other interesting percentiles as well as the minimum and maximum. I can also, from this drop-down menu, request it to give me the means and standard deviations. So the mean age for term deliveries was 27, and the mean age for preterm deliveries was 25.69. So those means are really tracking well with those medians. So maybe maternal age split out by term delivery may roughly be, kind of a symmetric type of distribution. All right, so if I want to start asking the question, well, is there a significant difference between the maternal age of the term deliveries versus the preterm deliveries, I move into my hypothesis testing framework. And one of the things I might want to use JMP to do for me is carry out that hypothesis test. And before I can decide what test to use, I need to know whether or not these variances are equal or unequal. The variances between the two populations, so the population of preterm and the population of term deliveries. And looking at the standard deviations here from the sample will give me some indication of how similar those will be. I really don't expect these variances to be very different, but I can do a formal hypothesis test to see if those two populations have equal variances, or more specifically to see if there's evidence that suggests they don't have equal variances. So the way I'll do that is come up here to the drop-down menu again, and I will just put a check mark next to unequal variances. And that brings up this section of the output here that says tests that the variances are equal. And what I really want to focus in on here is the f-test two-sided within this output. This gives me a p-value for that test. That p-value is large, and that means that there's not evidence to suggest those variances are different. So we can conclude that there's not a lot of evidence to suggest unequal variances, and so I can use my equal variances tests in this case. So I'm going to be comparing the means, and I've got equal variances, so I will use my two-sample t-test, or my t-test for independent samples with equal variances. Right, so it turns out that I can find that up in this little drop-down arrow as well. We're going to get a lot of mileage out of this, this one little window. So I will select means ANOVA pooled t. This pooled t is the giveaway that it's treating those means as equal. It's going to pool them together and give me my two-sample t-test for equal variances. So we'll click on that, and we'll expand this window. And you'll notice that as we scroll down here, it gives us a pooled t-test. It's telling me that it's using the mean of the premature, the mean age of the premature group minus the mean age of the term group, and it assumes equal variances. So a couple of things that I'm looking for here. This prob greater than the absolute value of t is my two-sample p-value. That's my two-sided, the p-value for my two-tailed test that is just asking, are they different or are they not different? Okay, so this is the p-value for my two-sample t-test with a two-sided hypothesis. Another interesting bit of information that it gives me here is the estimated difference of those means, and then by default it computes a 95% confidence interval for the difference in those means. So it says that it could be, the difference between the means could be as small as negative 2.69 or as large as negative 0.05. And then that tells me that it's using an alpha of 0.05 for this confidence interval and for well, it doesn't find the critical value, it just gives me the p-value. So we can compare that directly to, say, an alpha level of 0.05 or 0.01 or whatever alpha level you would prefer there. So this is really what you're looking for with that equal variances test. Now you might say, well, what if the variances were not equal? What if when I look at this test that the variances are equal and this f-test two-sided was significant? What if this was less than 0.05? Well, not a problem. We can go back up here and request it to do an unequal variances t-test, and that's done by, this one was the equal variances test, If I just select this one that says t-test, by default it will do unequal variances. So you could select that, and it's getting quite a bit of output in this window now, but this is what it just created for us, assuming unequal variances. And so now if you look at the confidence interval, that has changed, and the p-value has changed enough that now it's just barely on the other side of 0.05. So in this case, we would fail to reject the null hypothesis, but using equal variances, we would reject the null hypothesis. So this is a case where it's really important to carry out that equal variances test to make sure we're using the most appropriate, the most powerful test that's available to us. And that, again, in this case, is the equal variances test. Okay, so let me get rid of this output because that was based on the equal variances we wanted to use, or the F test, we wanted to use equal variances. So let's find that again. Here's my equal variances. And so looking at this p-value, I would state my hypothesis test. My conclusion is that I reject the null hypothesis, that maternal age is the average maternal age between preterm and term deliveries is the same, and conclude that there is significant evidence to suggest that the maternal age between preterm and term deliveries is different. More specifically, preterm deliveries tended to be younger. Mothers with preterm deliveries tended to be younger than mothers with full-term deliveries. Okay, and so I can state my conclusion that way. Okay, so the last thing that I might want to do here is do some sort of chi-square analysis. Maybe I have term and preterm, and I'm interested in creating a contingency table with maybe another characteristic of these moms, and that could be, say, their smoking status during pregnancy, whether they smoked during pregnancy, and see if there's a test to see if there's an association between preterm delivery and whether or not the mother smoked during pregnancy. So the way that I do this test is very similar to what I did for the last one. I'll come here to Analyze. I'll choose Fit Y by X. And so now I will specify smoking during pregnancy as my probably that's better as the let me get that out of there. That's probably better as my X factor, and then premature would be more like an outcome, and I'm interested in seeing how smoking during pregnancy has an effect on premature birth. And I can click OK, and this creates a 2x2 table for me, and you can see here that it labels it as a contingency table. Premature birth are the columns, and smoking during pregnancy are the rows. So one of the questions I might be interested in is, does the proportion of premature births, is it similar between mothers that smoked during pregnancy, those that said yes, versus those that said no? So I'd be interested in looking at the proportions that are listed within each of these cells, and there are several proportions and numbers that are given there. The first number in each of these cells is the actual count. So there were 606 term births where the mothers were not smoking. There were 99 term births among smoking mothers. Similarly, 78 premature births among non-smokers and 15 premature births among smokers. Now, this little legend up here tells you what exactly you're looking at in each of those cells. So the first value is the count. The second is the total percentage. So that's going to be the count divided by the total sample size. So this 606, this 75.94 should be 606 divided by 798. And similarly for 9.77, that should be 78 divided by 9 or 798, and so on. The next value is the column percentage. So this is basically taking this 606 relative to the column total, 705. So that gives me about 86% of this column. Similarly, this 83.87 means that 78 is about 83–84% of this column. So 78 divided by 93. And then the row percentage gives me just, switching where I'm looking at those totals. So 606 divided by 684 should be 88.6. That's the row percentage. Whereas 78 divided by 684 is 11.84. Okay, so it turns out that these percentages are these row percentages are the ones that are going to be interesting to us when we're looking at the rate of prematurity among smokers and non-smokers. Right, so there were 11% premature births among those that were non-smokers versus 13% premature births among those that were smokers. So about 2 points higher, maybe not quite 2% higher, of proportion of premature births among those that were smokers. And so one question that we might have is there an association between smoking during pregnancy and premature birth? We can answer that using the chi-square test for independence, and the output for that is actually given to us already. This has been calculated, and if you look under this tests section, this Pearson test corresponds to the chi-square test for independence. And so my p-value for that test is 0.5889, which is not significant at the 0.05 level. So if I were testing to see if there's an association between smoking during pregnancy and preterm delivery among this population, I would fail to reject the null hypothesis and conclude that there's not sufficient evidence to suggest that smoking during pregnancy and preterm delivery are associated. So there's not enough evidence to suggest that they're not independent here. All right, and so those are kind of the main points that I wanted to highlight because they correspond to the typical tests that we would talk about in an intro stats class, namely testing equality of variances, two-sample t-tests for equal and unequal variances, and then a chi-square test for independence. All right, good luck.